Good morning. We're continuing sketching quadratic equations. Let's quickly review our last time. You need to first know by heart the equation of x squared, a graph of x squared. If you have only x squared, nothing else, no other number else, it's the curve that goes through origin, 0, 0 starts at origin, there is a seed, and there are two branches sprout from it and goes northeast and northwest all the way up. That's what x squared is. Question is, what happens to x squared if you start adding numbers or subtracting numbers like -2 and -1 plus 1? If you add numbers to x squared, it goes up. If you subtract numbers from x squared, it goes down. That's it. Like blue and red curves. But if you start putting those numbers under the square next to x, it goes right if you add, and it goes left if you subtract. Is that right? Wrong. This is wrong. Addition this time moves it to the left, and subtraction is moving to the right. So right is when you have a subtraction, left is when you have an addition. This is wrong, okay? Look, subtraction moved right, addition moved left. So this is confused a lot, that's why I repeated the same mistake. And now we started putting numbers in front of x squared in product form. We multiplied it. When you multiply with big numbers, when I say big, 2 is a big one. You may say, oh, 2 is a small number. No, when I say big, means more than 1. If you put a number more than 1, it stretches up. Look, blue one. Black turned into blue, it stretched up. Sharper, steeper. And if you put a number smaller than 1, like 1 over 2 is 0.5 smaller than 1, then it relaxes. It goes under the black curve like red one. Okay? So just think vertically. This point dropped into here. And there was a point up there, it dropped into here. So everything is relaxing, getting wider. The picture is getting wider towards along x-axis, east and west. But if you multiply with negative big and small, same phenomenon happens under x-axis upside down. It stretches or gets wider or shrinks for big and small numbers respectively. 3 and 1 over 3. Big, small, but negatives stretched for -3 and shrinks for -1 over 3x squared. So this is pretty much the review of what we learned yesterday. The last thing we did was, these were all easy because they all these problems so far up to 8 had only one operation. Either you multiply, add or subtract, no combination of operations, only one operation was present. But the last question we did, 10 and 11, this had 2 operations, and this had 3 operations, or 3 transformations we finished yesterday. So this moved right, down, and upside down, and stretched. 4 things happened actually. It flipped upside down, stretched, moved right, and down. And I think it moved somewhere here like this, right? It was like this. Now we're gonna continue with the last remaining 3 questions, finish off this section, okay, today. And it's pretty much the same thing. You absolutely don't need any new transformation. You don't need any new tricks. It's all repetition of last concept. See what operations with what signs you have and decide which way shifts happen. Okay? So who can explain what 1 over 3 does to your picture? This is x squared. This is regular x squared But what happens if somebody put 1 over 3 in front of x squared? What? It makes wider. We call it shrink. It shrinks. Things start falling a little bit lower. Okay? What does this do? Putting a minus number, negative number underscore next to x. It moves left. Left 2. As much as this number. What is adding 1 does? Yes, it up. It moves up 1. So do all these 3 to this curve and you're done. In any order you wish, actually. Okay? So I'm going to first shift this thing left. Left 2. Left 2. And I have this picture now. No change in size. It's still same width. Okay? Second, I'm moving this up 1. Moving up 1. Up 1. Same width again. Left, up, done, done. There is 1 transformation left. We are going to now make it wider. 1/3, 3 times wider. So this is the final picture. Blue curve gets wider. Now I'm going to clean everything up. That will be our final picture. What is the fancy name for this minimum value, this deep down value here? What is it called? No, line of symmetry is the line that goes right between these 2 branches. So line of symmetry is this thing. I don't know if it's asked to draw, but yeah, it says graph, so we draw it as well. This is line of symmetry. I'm asking this red dot. What is it? Vertex. But what do I call it? I don't like this fancy name. What do I call it? What does it look like? Come on. What's the main subject of agriculture? What's the most important thing for a farmer? Seed. This is a seed. You drop it in a location and 2 branches grow from it. Okay? So it's all about locating where the seed is. That's so important. And I forgot to record the moves. It started, seed was at 0, 0, but I lost count. It moved somewhere and popped up here. Yeah, you can track it, backtrack it, and find its location. But I'm wondering if you can read me the location of that seed directly from this equation. Where is that seed? New location of the seed. I need you to give me 2 coordinates. Anyone? How? It has something to do with these numbers. 1, 3, 2, 1. Yep. It's opposite of this value, but same as the second one. It's positive 1. So take the sign. It's positive 1. So it's 2, 1. So we have a mistake. No, you're all sleeping. I found a mistake. It says seed is at 2, 1. 2, 1 is here. My seed should have been here, but my seed is there. The earlier seed is there. What was the mistake?
You don't flip the sign, in this case, of -2. You just keep it because you're going the same direction.
No, we should flip it to get the seed location. So the seed location must be 2, and this is wrong. How did my graph ended up being here?
Oh, because you weren't left, right?
Yeah, I said this is a left, right? But it should have been right shift. This is a right 2. This is up 1. So I can still fix it. Yeah. Instead of moving 2 left, we should have moved it 2 right, okay? And of course line of symmetry is no longer there. Line of symmetry is on the seed, right between branches. Okay. And now both the graph and the equation is justifying. This is 2, this is 1. Okay, I'm asking we found line of symmetry and sketched it visually, but I'm asking its equation. How do you find its equation? What is its equation? You don't recall? X equals
In that case, it's 2.
2. It's always x equals something. A vertical line has an equation as x equals a number. That number is always the first coordinate, x equal 2. Okay, let's carry on this into question so far and see what else is missing. So we first picked the right picture, and the right picture we found is it A, B, C, or D? What do you think? It's a U shape, so it's not gonna be B. B is off the list. Is it D? D has a seed on the -2, which should be positive, so it's not this. So you have 2 options, A and C. Which one? This is 2, 1. This is 2, 1 as well. Both graphs have seed on the right spot. 2, 1, 2, 1. But which one is right?
But can you go back up to see the problem?
Oh, you mean the top?
A.
It's A, why? Because?
Because it's spread out like
Yes, 1/3 spreads it out, right? Our branches are wider. It shouldn't be skinny like this one. So it's A. Okay, now it's asking where the seed is, and we already determined that it's 2, 1. The equation of the axis of symmetry, we already found that x equal to, it's x coordinate of the vertex, you set x into. What's the domain of any parabola? We mentioned this yesterday. It's always negative infinity to infinity. But the range changes. Range is when you smash this to y-axis. It's the image happening on y. So when you compress this sideways, if you push these points to the left, to the y-axis, what image do you get? Since arms are going up, we have this. How far do we go? Where do we stop? Stop at 1. This is the cutoff. You no longer have nothing under 1. So it's infinity to 1. from positive infinity to 1. 1 included. Agree?
No, you put 1 first.
Right. We read this bottom to top, small to bigger. So what's the big side? Big side is up here. So you need to start from small side. So this should be flipped. Okay. So I start with 1 and then put infinity. Alright, this completes the question. Alright, 13. Give it a shot on your own. Okay, we still have 3 transformations here, actually 4. Tell me first, what does this minus do? It flips. Flips upside down. What does this 4/5 do? Shrinks or stretch? Stretches? Why?
Because it's a fraction.
Well, this was a fraction as well. 1/3. But it shrinked it. Got wider. Fraction or whole number is not the criteria. What is the criteria? Less than 1. Take a calculator, divide 1/3. Is it less than 1? Yeah, it's 0.333. Take a calculator, divide 4 by 4/5. You get 0.8. Is it less than 1? Yes. What if this was 6/5? This is more than 1. This is a stretch. But with 4, this is less than 1. It's a shrink. Slightly shrinks it because it's really close to 1. So it's gonna slightly shrink it, not huge. Alright. Like you're the size of 0.8. Like instead of 6 feet, you're 5 something because 0.8 is gonna shrink a little bit. Okay. Alright. What is this minus 4 do? Next one. It's right 4. Good. Whereas 3 do? Past the 3, up 3. 4 operations, do it and we're all set. Let's first flip this thing. Is that right, flip? I flipped it, is that right? Correct? No. When I flip, the vertex shouldn't move, it should stay on origin. So this is the right flip. Okay? So this was going up here. The seed must stay and branches must go down. Okay? So I flipped it. 4/5 is going to make this thing wider. So I'm going to make it a little bit wider. Okay. Now I'm marking the things I did. Okay, so this is done. This is done. Next, we are gonna move this right 4. 1, 2, 3, 4. This is at 4 now instead of 0. By the way, I don't need this thing anymore. That one gone. So check. Now we're going to move it up 3. 1, 2, 3, 3, and stop. So this location is 3. So if you have been tracking my moves, 4 right, 3 up, this is 4, 3. Or if you haven't been tracking these numbers, I can read the vertex here. Vertex is opposite of this number, comma, second number, 4, 3. Okay, there's something new asked in this question. You're gonna decide whether this looks like a maximum or minimum. What do you think?
Maximum.
It's a maximum. It's like a mountaintop. It's a maximum. So we have a maximum point, not minimum. But what is that value? How high is this mountain from the ground? It's asking the height of it if you have a maximum. What is this height? It is 3 because you can read it. What if I erase this? How would you find it? If I don't say this, how would you find this from equation? How would you find it? What number do you think that is? Where is it hiding? Maximum or minimum is where? At the end. It's this number or second coordinate of the vertex. Okay? Either this or this. You can find it in 2 spots. If you already have vertex coordinates, it's the second one, second coordinate, or the number on the very end. Okay? So let's fill in the blanks now. I think we first choose the graph. No. We first determine the vertex. Look, I don't even need to sketch it. I just look at these numbers and write the vertex. 4 and 3. Second. Is that a maximum or minimum? Oh, by the way, you decided this is maximum or minimum from the picture. I gave you the picture, you just named it. What if you don't have a picture? What tells you in this equation you have a maximum or minimum? What? There is...
Or if the beginning is negative.
Right. If this number in front is a positive number, then it's a minimum. If it's a negative, like this question, negative number, then it's a maximum. So this is a maximum number, maximum point. And that maximum value is always second coordinate or the number on the very end. Okay? And the last number is quite different. No, it's not quite different. It's not just asking any graphing though. Okay. Why don't we give it a shot? Or you can tell me actually, what is the vertex? We need to find vertex first. I'm not even sketching it. Look, I'm not sketching nothing. I always first sketched and then cheated the answers from the graph. I'm not doing it this time. I can do all this at once. What is the vertex?
1 and 1.
Perfect. Done. Is this a maximum or minimum? When you graph this, are you going to get a mountain or valley? Are you going to get the maximum point or minimum point? Minimum. Why? Because of this, it's positive. If it's the number in front positive, you have a minimum point, not this. So we answered 2. Okay, what is that maximum or minimum value? We don't have a maximum, but what is that minimum value? Right? Negative and half. That's it. 10 seconds question. You don't need to graph it. Nothing, right? Was that minimum? Positive 4. And the negative 1/2 is that minimum value. Okay, I want to ask one more thing. Can you tell me the equation of symmetry, axis of symmetry? Symmetry equation. You don't need the graph.
X equals 1.
X equals 1, yeah. Okay? Alright, this is all. Now, do you all appreciate the value of having a quadratic equation in vertex form? What is this called again? This is called vertex form. I call it seed form. Why do we need to appreciate this form? Why? Because under 10 seconds you can harvest all the information about this function. Maximum, minimum, it has a maximum or minimum, vertex, axis of symmetry, everything is hidden in there in 10 seconds. Can you do it in standard form like this equation, if this equation was in this form? Could you read the same all information from this equation? This is standard. If you FOIL this, multiply by 4 and add -1/4, this is what you get. Can you read it? All this information you got 10 seconds here from here? No, you can't. So finding seed form so valuable. So we need to be really thankful for that. Actually, you will be very thankful if somebody gives you that, because finding this vertex form takes some effort. In this section, and that's the last section in this course, I will show you how to turn useless form. I call this useless standard form, useless standard form. How to turn it into useful seed form or vertex form. Okay? This is our topic today. How do you change something completely, totally useless into something amazing that you can get all information in 10 seconds? Are you wondering how? Look, they did it one for us. There was x squared, 8x, and 13 given. They turned it into x plus 4 squared minus 3. This is the vertex form. I can read the vertex. It's -4 minus 3. I can see its minimum value. Minimum is -3. I can see its symmetry axis. It's x equal 4. Look, in 10 seconds I have all data ready because somebody did the hard work for me and changed this useless thing into something valuable, right? But the question is, how did they discover these numbers from here? Because I see no relevance. 8, 4, 13, 3. I have no clue how they got them. Well, I'll show you. Okay? You understand? You need to understand first why we are doing this, okay? We're just turning something totally useless into something useful. Again, another benefit of having this form is you can graph these quickly because this says left 4, up 3. I can quickly graph using this, but I cannot graph with this. Cannot graph with this. Because I don't know how 8x and 13 is going to shift my things, okay? But I can do it with +4 and -3. You can get this graph in 10 seconds with this, but not with this. That's another added bonus, okay? Here is how we are going to turn the standard useless form into ax minus h squared plus k. And you need to really listen carefully here. We've done this in the past actually, it's not new. A little modified something we've done in the past. First, check out step 1. A equals 1 or not? What is A? A is the number in front of x squared. What do you see there? 1. If it is 1, you can relieve. It's good news. This is good news. You don't have to do step 1. Can I quickly peek at the next question? What do you see? What is A here? 4. We are going to do a real step 1 here. That's bad news, because we are going to do one more extra step. Yeah, we will separate that 4, factor that 4, okay? To get 1, yes. But just wait a second for that. So we don't have to do step 1 here. So let's do step 2. In step 2, group x values under the same parentheses and leave out the constant. Write this down in sentence if you want, if you're not gonna recall it. Group x's under the parentheses and leave out the constant far, far away. It's not gonna be our concern for a while. Like this. This is what I mean. Step 2. Just take a parenthesis and some space and leave this 6 out of business. Everything will evolve here. I'm leaving some space here. Okay? Make sense? Alright, here's next. Whole idea behind turning useless form to useful form is, look, compare. You need to see this difference. Here you have 2 spots with x's. You have a single spot with x, and its x's are packed under a square. We need to turn x's into complete square. We've done in the past something like this, correct? So I want you to turn this into square with x with a number next to it. But we do know that in the past, to turn something x's into square, we need 3 terms, not 2. Okay? Yep. Yep. Exactly. We are going to take half of this number, square, and put it here. So what is half of 6? Positive 3. Yeah, go with the sign. Positive 6 has half. Positive 3. And square it and put it here, which is 9.
You do it to the outside as well, or no?
Yes, good comment. We just added something to the right side of an equation. There is an equal sign here, right? Is it fair? Can you just add a number to the one side of the equation? It's not fair. So to make up for this, you have 2 options. You're either gonna put it to the other side as well, next to f of x, or some people rather do it this way. They put minus 9 to this side. Do you see why? Because 9 and minus 9 will cancel, the total effect will be 0. Or some people want to be fair. I'm putting 9 here, then I must be putting 9 there. But wait a minute, if you move this 9 to the other side, it's going to make minus 9 anyways, right? So which way you want to do it? You want to put it on the left or put it on the right side with a minus sign? Do you care? Put it on the right side? Okay. So that's what I'm going to do from now on then. If you put a number here, we move that number with opposite sign. This is positive, with opposite sign to here, so that they can cancel away. It looks like as if I did nothing to it, because x squared plus 6 again. Look, x squared plus 6x plus 6, same 3 things here. I just taking back what I did later, but it's gonna take a while. Okay. Now, once you have 3 terms here, you can turn it into a complete square with what number here? Tell me. What number is that gonna be? 9? It's 6 or 3? It's 3. It's this number, half the quantity here, or square root of this number with this sign. Square root of 9 is plus minus 3, but we go with the sign in the middle is positive 3. Okay? Now what is this? 6 take away 9 is minus 3. Alright, mission accomplished, you're done. Look at this. Let's compare these two boxes. Box 1, box 2. Are they look alike? Do you have x, a number under a square? I have x. I have a number. Although it's plus, it's okay. This doesn't necessarily mean minus all the time. Sometimes this can be plus. So I have a plus. It's fine. I have a square. Yep. I have also a number, but this is a plus. I got a minus number. It's okay. These signs can flip. Okay. They don't necessarily mean minus and plus here. It can be opposite sometimes. But there is one thing missing. I didn't get A. Where is my A? Why do you think I didn't get any A in front? Yeah, because it was 1. So this thing is still 1 there actually. A is 1. Okay? So this is called vertex form. Or I called it seed form. Or useful form. Whatever you call. Okay? But this is what we've been looking for. It's time to rip the benefits. What's the benefit of this form? You can find max min. You can graph this in 5 seconds because this means left shift down 3, right? Left and down. And what else? You can determine axis of symmetry. Most importantly, and this is what is asked only here in this question, you can find where that seed and branches are going off from there. Where is that seed? Vertex. Where is vertex? -3, -3. Opposite of this number and the second number actually itself. Right? Okay. So what do you think? Looks standard procedure we've done before, but there are so many traps you can fall into, make mistakes. So you need to really master this, practicing and practicing, okay? And trust me, when you go to college algebra next semester, you will be doing this again, okay? A lot earlier, not on the end of the semester, but in one of the first 2 chapters, you will repeat doing this, okay? So it's better you learn now than later, okay? While I'm opening a new one, why don't you try this question ahead of me? 4x squared, 10, 40x, and 15 plus 15. Same work. This time you have a 4, nasty 4. I will show you how to tackle it. But let's just try on your own, see what you can do about it. Four x squared, 40x, and 15. Alright, we have a real step 1 here. A is not 1, it's 4. Here's what we need to do about it. This is step 1. We need to factor out 4. Divide terms with 4. However, you need to do it among first 2 terms only. Leave out this one. Leave this guy alone. So that 15 has to separate from the group and stay here. You're gonna factor 4 from first and second terms only. That's it. Factor 4 from first and second terms only. Extremely important, because I see people are factoring 4 from everyone, all 3. No, 15 is not in business. Okay? So what is left if you divide 4x squared by 4? It's just x squared, right? How about 40? Divide 40 by 4, you get, what is 40 by 4? 10x. Alright, I need a little bit space here. Guess what's coming? You need to have 3 terms to combine into a square, right? I'm gonna get, yeah, that's fine. So, is this first step clear? Let me do the second step now. Step 2 right here. We're gonna bring in a guy here, which is gonna help us combine this into square. What is that guy? Right here. Perfect. You take half of this guy, square it. There you go. Now we have to take back what you did from the end, because you have brought some extra weight here. You need to lift those weight off. How much you're gonna subtract here? How much you're gonna subtract here? Let's see who's smart. You guys are half smart. No, you're smart, but you know, you have to take this number in off here. 9 and minus 9. This one has a challenge. Think again. Are we gonna take off 25 again?
-5.
Nope. 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 Think again. Look, I added 9, took 9 out of, because there is only 1 9 I added here. You no longer 1 in front. Yeah. When you add 125 here, it's multiplied 4 times. Scale of 4 later. So this 4 kinda quadruples it. 4 times 25 is what you actually added it. So it's not fair if you just take 125 off. It needs to be 4 minus 25. So that's not 25, it is 4 times 25 is, you need to take off 100. So this is very important, okay? Okay? Most mistakes happen here. Oh, you add 25, you subtract 25 here? No. You added 4 minus 25. So you need to take 4 minus 25, 100 off. Okay. Now let's turn this into a square. This parenthesis becomes a square with x and plus 5. What is 15? Take away 100? Negative 85. We're all set. Mission accomplished. Yeah, it should be 5. My 4s look like 5 sometimes, or 5s look like 4. Alright. So read the vertex. That's it. We're done. What is vertex here? Vertex. Vertex. Yes, thank you. Alright, let's put this in here. So 4x minus or plus 5 squared minus 85. Check. Need to read the vertex. -5, -85. Check. Alright, good. We passed the hard part. The next time on Monday, I will show you the formula option to find vertex form. There is a formula that gives you this form directly. I hide it to the behind second part because I wanted to learn this method, because this method is used on other chapters in 1148 next semester as well, like in circles. And if you go with higher up in calculus courses, this completing into square is extremely good tool. So you need to know this, but if you want to test your result correct or not, there is a formula option which I'm gonna give you on Monday. Okay?